Hi guys, welcome to the channel. We're going to do something different this time. I'm going to take you through a real live interview question that I was asked, because I think it might be interesting to go through how one would answer a particular interview question. It's quite a simple problem. In this case, I have started up a little console app here where I have some data in an array. Could be a collection node, doesn't have to be an array, could be a list, something like that. And the question is how would I determine the count of the number of elements in the array that were even? So we can have there's a particular mathematical function called a modulo operator that basically returns the number of things left over in integer division. So if you said divide 5 divided by 2 in integer division, you would because we're not dealing with whole numbers, we're not dealing with floats or doubles or anything like that, we would get 2. So 2 goes into 5 2 times. We wouldn't get the remainder because we're not dealing in floating point. If you wanted to find out how many things have left over, you need to use the modulo operator. In this case, 5 modulo 2 is 1 because 2 goes into 5 2 times with 1 left over. But if you modulo an even number with 2, you get 0 because there's no remainder. 2 goes into an even number a whole number of times with no remainder. So that's how you detect an even number. There are a few ways to do this. A couple are they're all loop based, except for one, so they're not all loop based. So let's just jump right in. The first one is the classic for. This is a standard for loop where we have an indexer, in which case we call it I. It's quite a common temporary variable name. We have the beginning condition, I equals 0. We have the increment condition, I equals I plus plus. I increment I by 1 each time. Then we have the ending condition, which basically says if we are greater than the length of the array, then we stop. We're going to need a counter because I'm going to initialize that to 0. Okay. And we're going to say if data I is modulo 2 equals 0, then what is that? Oh, I'm having a brain fart here. That's the ending condition. This is the implementation. This is the iterator condition here. Being an idiot. Sorry about that, guys. Yeah, so we have the start condition, the end condition. This has to be true in order for this to continue. And we have our increment condition. Okay, so we can access the array directly through the indexer. We're going to go from 0 to the length. So while we're less than length, we're never going to hit this imaginary element here. And we're going to say if our current entry modulo 2 equals 0, it's even, we're going to then increment the counter. And what we can do is we'll output the 4 gives us counter 1. And then if we use our special string formatting command here, if we run that, we will get a number. And that number is 5, which is correct. Next one is very similar. In this case, it is called a for each loop. And you can have derivatives of the for loop. You can have a do while, or a while do. But this one is a particular for each loop. We need another counter 2. We'll output that. We'll change this. And we're basically going to say for each our entry in data. And this uses an array exposes an IEnumerable interface. And that an enumerator is basically a special interface that you can say, right, get me the next element, return the current element, and all of the code constructs around that can use that. So here we go. So if it's modulo 2 equals 0, then we increment the counter 2, not counter 1. Run that, and we should get the same answer. We do. Great. The next method is we use something called link. Link is a type of way of interrogating data that's kind of more human readable. It's quite advanced. It's used a lot when accessing databases and stuff like that, but we can use it here. And we'll say counter 3. I can spell. And we go data.where. I have included the using the systems link here already, so this is why this is already coming up as being. We use something called a lambda function here, and that basically means that the where says we're going to go through the IEnumerable, and it basically we have a function of a predicate, and that's what we're basically specifying here. Or we're going to say modulo 2 equals 0. And when we have that, so that creates a IEnumerable of a subset of the data where the particular entry of the data is fulfills this requirement. So we're only getting the even numbers. And then what we can do is we can say, give us the count for that. And that's quite nice. You know, you can see it's quite succinct. If you're on that, yeah, 5. Now, in both of these cases, the amount of data that we are dealing with is known up front. It's known at design time. Yeah, you can specify, okay, we're going to read a file. It's got 1,000 numbers in it. That's fine. But what happens if we don't know the amount of data that we have? And that's what I'm writing now. Except I can't talk and type at the same time. And so in this kind of situation, what we have is we have a stream of data, perhaps from a socket, from another server. We're reading from a database. We have been provided with a text file or something like that, and we have absolutely no idea how much data we're dealing with. We could be dealing with one number. We could be dealing with 1 million numbers. I've used API like this where you don't know how many records you're going to get back. It makes it very difficult to write something, taking advantage of certain optimizations. Because what you don't want to do is, say, for example, if you were returning 10 million numbers, you don't want to load all 10 million numbers into an array in memory because you're going to run out of memory. And so you want to do it in such a way that allows you to examine each element of the data stream without actually having to load the entire data stream. And you can do that. And so we need to create another function. And what we're going to do is we're going to have another for each, because we're going to using the IEnumerable. We're going to say in data. And then what we have is we have a special keyword called yield. And what that does is it basically says, okay, it kind of like puts a bookmark in the collection of where you're currently at. So if you're on item 0, when you return 0, it puts a kind of like a bookmark in. And so the next time you call this function, it remembers where you were last, and then it moves along and returns the next item. And so we don't have to. It's not kind of like a bookmark, but it basically knows the last item, and then it calls the get next item on the IEnumerable. And call this one yield, if I can spell. And the way that we do this is it's pretty much the same way that we have before. We need a counter. That's 0. And we say for each var entry in get next entry, providing the data, the collection that we're looking for. And we're going to say, again, if if entry modulo 2 equals 0, we can increment our counter. And then what we can do is we'll output this. And if we run that, we will see that they all give us the same answer, which is great. This is the right answer for this particular interview question. You could say how many are odd, or how many are even, or other such things. In this case, it's basically a question of, do you know this one and this one? Because everybody knows, or should know, this one and the for each. But it's knowing when, some people may not know this one, so that's quite nice to be able to present that, to say, hey, I am aware of LINQ, I have used it. Some people may not be aware of this one and the reasons of why you would use it. Anyway, I hope you guys found that educational and useful, and like I said, any comments or feedback, don't hesitate to add it to the video comments. And if you do like what I'm doing here, think about subscribing and clicking that button. That'd be great. Thanks very much. Take care.